Okay, recording is in progress. Hi, everyone. I'd like to start my presentation by saying thank you to the Forces of Defense of Ukraine who protect my life and the life of my daughter and the life of everyone I love and everyone in Ukraine. Glory to Ukraine. Slava Ukraini. So here on the slide, you can see a QR code for the Slido where you can ask questions if you want to ask an anonymous question, or if you're in Zoom and don't feel comfortable unmuting yourself. But at the end, as Tanya said, you will also be able to just raise your hand and ask a question. So I'm just giving you 30 seconds. Yep. Okay. Everyone's happy. Good. Great. Okay. The clicker doesn't work, of course. Okay, Tanya, I think the battery is dead. No, doesn't work. Okay, we'll start here. A couple words about me. I'm a computational linguist. I have with more than 10 years experience in natural language processing projects. I'm tech lead at Grammarly, leading the team of computational linguists. I'm also the general organizer of the Ukrainian natural language processing workshop. At work, during the day, I work with the English language, but at night, during the night, I work with the Ukrainian language. And I'm also a member of the Lang UK. This is our organization where we publish open data and open tools for the Ukrainian language. And I also serve as an expert on the expert committee on the development of AI in Ukraine under the Ministry of Digital Transformation of Ukraine. Additionally, I also supervise master and bachelor thesis at the Ukrainian Catholic University, and this is how I know Tanya, who started this meetup. Okay, moving on. Here's what we're gonna talk about today. We will start. Tanya, what are you doing? Stop clicking my presentation, thank you. Thank you, Tanya. Great, okay. We don't need this part of the clicker, right? Do we? Okay, thanks a lot. That's better, thank you. Okay, so we'll start with the motivation about why we need anonymization in general. Then we'll discuss different flavors, meaning types of anonymization. Then we'll dive a little bit, not very deep, to the techniques of anonymization metrics. And I have a teaser prepared for you for the end of today's night, if we have enough time. I hope we do. So let's start with motivation. Why would we need to anonymize text at all? So imagine this is your app. Okay, this is your app. And this is your user. And actually, you're a successful app, so you have a lot of users. Yeah. What your app does is it processes user text. Maybe it does sentiment analysis, maybe it rewrites stuff, maybe it summarizes text, maybe it, I don't know, just generates text. So it can do whatever you want. For the purposes of development, error analysis, debugging, whatever, you want to store some of the user's text. But not all of your users may appreciate you storing their text, right? And some users may even get angry and may start writing hateful comments about your app, right? And this is where you get a conflict. Like, you want user data in order to improve your product or to do error analysis or to do what you do best. But the users want to protect their privacy, right? They don't want their sensitive data to be stored somewhere in your database or sent to a third party or whatever you want to do with this data. The situation is even worse if the text that you are processing are sensitive, like it could be legal contracts, or medical notes, or psychological evaluations, or even messages on dating websites. You know, people won't appreciate you saving their messages of dating websites in your database. Or it can be internal business communication with some, sensitive deals or something. So the best way to alleviate this situation, to meet both goals, to protect user privacy and also to store some data, is you can add anonymization somewhere in your architecture. And you can actually add it in multiple places of your architecture. It can be on the client side, it can be on the server side, it can be on the database side, like whatever. And this will make users happy, right? Well, not all, like this one will unsubscribe anyway, regardless of what you do. But most users will be happier. When we're talking about text anonymization, we discuss it as a responsible AI practice, and that's why I'm discussing text anonymization at the Responsible AI meetup. This is what you see here on the slide are 6 principles of responsible AI from the Microsoft Responsible AI standard. And one of the principles is privacy and security, where text anonymization falls, right? In addition to being like ethically responsible, when handling users' data, there's also a legal part to it. There are multiple regulators in multiple locations around the world. Like in Europe, we have GDPR, General Data Protection Regulation. We also have like HIPAA or CCPA. This is California Customer Protection Act in the US, and multiple like other local standards. In China, they have People Information Protection Law, for example. In Ukraine, we have the Ministry of Digital Transformations that already has recommendations about how to anonymize personal data before it's being published on the data.gov.ua. This is the public portal of open data. There are also ISO standards that some companies have to meet in order to get certification. And these standards also describe what personal data needs to be anonymized and when. When you're thinking about what to anonymize, there are multiple criteria that you have to think about. Like, first of all, user controls. Like, can your user opt in or opt out of anonymization explicitly, right? Maybe you tell your user, if you don't anonymize your data, then like the quality of the product will be better. Data sensitivity that we discuss, like think, for example, user essays about whether smoking is good or bad, which should not contain any personal data, or like psychological evaluations that may, be full of personal data. Are you sending this data to third parties? Maybe your users trust you, but don't trust third parties, for example. What's the intended data use? Like if you're doing error correction, probably you know some apps that do error correction here, right? So if you do error correction, like do you need to have all the user emails in the text and know them and store them? Like probably not, because you're not correcting errors in user emails, and so on. So with this motivation, I hope it's clear that why we need to do text anonymization. It's because we want to protect user privacy, and it's because we want to still have some data for us to improve our models. So let's now discuss anonymization flavors, like what types of anonymization are there. When we say the word anonymization, it's quite ambiguous. So it can mean different things. And I will start with two notions. Like one is pseudonymization, the other one is de-identification, and we'll discuss the difference between the two. You may find like different definitions of both of these, because you saw how many regulators there are in the world, and all of them define these terms in very different ways. So we will stick to the definitions from GDPR and from CCPA here. They mostly, align. If you find different definitions in the website, that's okay too. On the web, that's okay too. So by anonymization, we can mean, for example, pseudonymization. When we say pseudonymization, it means that personal data can no longer be attributed to a specific person unless we use additional information. And so this part, unless we use additional information, is like very tricky because you can interpret it in multiple ways. Like in one way that you can interpret it is that there are some other identifiers that have not been anonymized. And if you, use Google, then you can re-identify the person, and it doesn't matter that you anonymize part of it. The other thing that it can mean is that maybe you found personal data, like, emails, for example, passport numbers, phone numbers, and so on. You substituted them with some codes, and you kept the mapping somewhere, And so you sent the anonymized data, further somewhere else, but then you keep this mapping in a different place, which means that technically you can re-anonymize the data back and get the original data, right? Why would that be useful? Okay, just think for a minute, like why would such an type of anonymization be useful? So if you remember what I started with an app, right? And that you can put anonymization in multiple places with software. Let's think of a situation when you want to do client-side anonymization. So anonymization happens on your phone before any text that you write goes to the server, for example. So what happens then? And say, again, this is an error correction app. So if this is an error correction app, the user writes, this is the part that happens on the client side, on the user side, on your phone, and this is the part that happens on the phone. So we anonymize and de-anonymize on the phone. So the user wrote a sentence, the report arrived on me at gmail.com, and the sentence has some errors. So what we do, we first anonymize the email, right? And we keep the mapping somewhere on the user side. So after we anonymized it, we send the sentence to the server for it to correct errors. And we your app corrects, like on the server side, you correct the spelling error and the preposition error, and you send it back to the user. When you send it back to the user, you de-anonymize the email, and then you can send the output of your program like back to the user. So this is how you do pseudonymization, right? You have the mapping, you can de-anonymize this email back when you need. Another example from like closer to our Ukrainian context is our portal of open data, data.gov.ua. So on data.gov.ua, we have a registry of court decisions as open data, right? So multiple courts in the country, they work like every day, they generate multiple of these court decisions, and they're obliged to publish this data as open data, right? What they do, they should pseudonymize instances of personal data that rely to the plaintiff or to the defendant. So they would frequently use the word like osoba to mask like the person that was at this that was mentioned at this place, and like this they would keep it deterministic. So this osoba, everywhere that a specific person is mentioned, they would have the same identifier. But the court still has the original text, and the court still has the mapping that they used, right? So they would use pseudonymization technique in order to publish this data as open data, right? And comply with the recommendations of the Ministry of Digital Transformation. Let's move on now. De-identification. It's similar to pseudonymization with like one tiny correction. It means that personal data can no longer be attributed to a specific person, period, right? Doesn't matter whether you have Google, doesn't matter whether you have, you don't have any mappings, you don't have anything else. You can no longer re-identify this data. Then it's considered de-identified. And there are two ways to approach it. Like you can mask the data with the identifiers like osoba, meaning like person, or like organization, location, and so on. Or you can do rewrites, meaning replacing a specific name with like another name, another random name. So let's see how it works, what the identification looks like. Here we have original text that says, Lee Davis, a prison officer at Leeds Prison, regularly supplied cannabis to inmates, getting paid £400 to £500 for every package. And here we have some personal data. We have the full name of the person, we have the organization where the person works, and the sum of money. When we do masking, the result of anonymization would look like this. We would have a person, org, or organization, or whatever you want, and money here, right? So this would be called masking. And this would be called a rewrite of the identification. You would have Lee Davis substituted with something like Michael Green, then Leeds Prison changed to North Prison, and the sum of money also like a generated one. Okay, so hope the concepts are clear now. The question arises, but like what to anonymize? Like how do we know what is sensitive and what is not sensitive, what is personal data, what is not personal data? In the domain of anonymization, we differentiate between direct and indirect identifiers. Direct identifiers are unique to a given individual, and they disclose their identity. It's like your email or like your full name. If it's like unique enough, if it's not John Smith, it can identify you, or your passport number. Indirect identifiers, in isolation, they don't identify you, but when you combine them with other indirect identifiers, like you get enough evidence that can re-identify a specific person. And we'll look at some examples. Well, first we can get back to this prison officer, right? So there's one direct identifier, is their full name, right? That identifies this officer. So say we mask this full name. How many indirect identifiers in the sentence do you see? And this is a question to the audience. You can just shout it out or whatever. 2, okay, 3, I see 3. Yeah, okay, 4, great. Andri Larkin, okay. So 4, I found 4. So if you don't know the name of the person, but you know where the person works, you know the occupation of this person, that is a prison officer at Leeds Prison, you can just get all prison officers from there. You have the age of the person, you can just filter by age, for example, and then you have how much money they got for this cannabis. This actually can give you a hint at how much they earn, or something like that. And so on. And we can play this game even more, right? So it's not exact science, just for you to understand. So just this is for the intuition about what direct and indirect identifiers are. Some examples from the ISO standard about direct and indirect identifiers. So direct would be like full name, address, email, phone number, social security number, credit card number, and so on. So things like this. For indirect, it can be your nationality, religion, gender, job title, city of residence, marital status, even your revenue can be an indirect identifier. So this just gives you an intuition. It doesn't mean that you have to anonymize everything in every case, in every sentence, for every domain, and at every app. Like, no, none of these regulations, none of these standards have exact numbers of quality that your anonymizer should reach. They just give you recommendations that you should anonymize as much as possible, depending on the intended use of data, on whether the user has controls, on the data sensitivity, and so on and so forth. So basically, you should do your best to anonymize your user's text. Let's see at some other examples. I like this paper, TILD. I'll mention it again a little bit later. It has very, very interesting examples of indirect identifiers where like everything is anonymized, but you can still guess who we are talking about. And this is again a question to you, to audience. So let's look at first example. Person 1, nicknamed the Iron Lady, served as location 1, occupation 1 from date 1 to date 2. Who are we talking about? Margaret Thatcher, right. Then other one produced and recorded a variety of musical hits, such as Other 2, Bohemian Rhapsody, and Other 3. Oh, Freddie Mercury would be a person, right? And here we have Other, Queen, right, correct. And the third one, this is the most complicated. So person 1, known for pronoun role, as person 2, struggles to say the word penguin. Benedict Cumberbatch, right. Great, yes, so these are the correct answers. Great audience, you know pop culture. Let's go on. Now let's move to anonymization techniques. So now you have an understanding of what types of anonymization exist, right? Pseudonymization, de-identification, masking, rewrites, and so on. So let's talk about anonymization techniques. Let's just discuss this use case. So we have original user text. We want to anonymize it. And then after we anonymize it, we can store it. We can train models on it. We can test models on it. We can calculate some statistics on it. We can do whatever we want on it after anonymization. So how do we do that? There are two directions. One direction is to do it as a one-step approach. So you would fine-tune a sequence-to-sequence model to do text anonymization. You rewrite from one sentence to another sentence. Actually, I haven't seen any successful cases of that, but the idea is a good one. The only pro is that it's very simple, right? It's a simple idea. You take a parallel text, you train a model, and that's it. The problem is that there are no golden corpora for this, even for the English language, right? No one knows what golden standard is in this case. And the other con is that you actually have less control over what is identified and what is anonymized. So you cannot like fix one or the other part of it. And you can check a paper that is called Privacy and Utility Preserver NLP with Anonymized Data that my colleagues at Grammarly published last year. This paper actually compares this approach to two-step approaches that we're gonna discuss later. So the two-step approach, which is more popular in the industry, is that you first do the detection and then you do the replacement, right? And there are multiple ways you can detect spans of personal data, but usually it goes down to named entity recognition. Named entity recognition as a natural language processing task, when you would find entities in the text. And you can find these entities using like regular expressions. For example, if you have to find emails or phone numbers, you don't need a large language model to do that, right? You can do this like very easily, and there are already ready-to-use tools that you can do. You can use dictionaries. You can try to fine-tune a model, and in the current era for named entity recognition, fine-tuning a transformer model would be like your choice number one. For detection, for replacement, this is a more interesting part, and we're going to discuss how to use dictionaries or ontologies or rules for that. You can also prompt an LLM, but there are some problems with it. We will also get to that. So let's start with detection. For those of you who's not familiar with named entity recognition, this is a sequence labeling task where you would simply label each token with a type of an entity. And O here means other, meaning like not an entity. So like Apple would be an organization, Tim Cook would be a person, and April 12th would be a date. Specifically for anonymization, there are a couple of things that you can use. So first of all, there's a procedural library developed by Microsoft under an MIT license, so it's open for everyone to use. And what this library does, it has a list of dictionaries and regular expressions to get like to match entities like phone numbers, emails, social security numbers, and so on. Then also you can use Spatie or Stanza named entity recognition models, like for any language, basically. Although it's originally developed for English, and I think Spanish was also there. As far as I know, they started supporting Hugging Face models too for named entity recognition. And the interesting thing they also do context analysis, because not all entities have to be anonymized in all cases, because sometimes entities are If you have just a list of companies, I'm going to show an example in a while, they may not disclose a person in any way. They're just companies. They're still entities, but you would, if you don't do context analysis, you would still anonymize them and you would just corrupt the data that you have unnecessarily. There's also the project started in 2018 and it's actually still being developed. So it's in active development. It's a cool project. Then there's also text wash that was developed 2 years ago by a team of University College of London. Currently it supports English and Dutch. What they did, they annotated portion of British national corpus and some other corpus, so they annotated them for entities, specifically for entities that they considered sensitive, or they took Enron. So British national corpus and Enron emails. There's a corpus of Enron emails. They annotated them for sensitive entities and fine-tuned a Roberta model to do that. This tool is also released under an open license, so like anyone can use, and it's an active project still. In addition to these two open tools, there are also multiple named entity recognition models in popular libraries like Spaces, Danza, and Player, and they're available for a variety of languages. And a hint, Ukrainian is available in all three, just for you to know. Licenses vary though, so this is not something I can specifically say. So as I mentioned, not all named entities need to be anonymized. So here we have a sentence that says, Bain Capital owned data center operator Churn Data Group Holdings Ltd is in discussion with lenders for a potential loan. And actually, none of these, there are a lot of entities here, but none of them disclose any personality, any specific subject, which means that ideally your anonymized text would not change from this one, right? So that's why you need context analysis in anonymizers, and that's why anonymizers do not equal named entity recognition systems. Moving on, so we did detection, right? Say we have our named entity recognition model with context analysis that can find sensitive spans and can label them with some specific types. Usually you would want to have first name separately and second name and last name separately, but I combined them here, never mind. So what do we do next? So, and this means that at this step, you already have masking, but you also want to have some kind of rewrites, right? So let's talk about how we would find a replacement for each entity. And here are a couple of tips to start with. So first of all, replacements can be deterministic throughout text, which means that if you have the same person mentioned multiple times in the text, you would want to anonymize the same person with the same random name, right? You wouldn't want to change the integrity of the text because then the text would be of worse quality. It's fine, as long as you don't keep it throughout text, as long as you don't keep this mapping table somewhere, in your system. We want the text to be realistic, right? So we want names to be substituted by names, last names by last names. We want to have dates have the same format that they were in the original text, organization names by organization names. But you don't want it to be too realistic. Here's a cute story. So if you take a credit card number, right, you find a credit card number, and then you substitute it with random numbers, you may sometimes get a valid credit card number, right? Which may be a problem with the auditors and certifications for a company. Changing it to 1, 2, 3, 4, 5 is usually a better choice. Moving on. So the most obvious way to do replacements is to do it by having property-based word lists. So you would have a word list of first names, a word list of last names, a word list of nationalities, a word list of city names, and you would just randomly pick one. Or you could also improve it by having like a smarter ranking system there so that you don't have any bias. And we'll look at some examples later. The other approach that is used is ontology-based, which also has its problems, but has its virtues too. So say you have an ontology that has multiple people, multiple organizations, multiple locations, and so on in this ontology. And you want to anonymize, a person. So you would find a leaf node in this ontology that matches your entity, but this means that your entity has to be in ontology, right? That's one problem. Then you traverse the graph to extract sibling nodes, and you generate candidates based on properties. And some examples. So if you have a person and you want to anonymize this person, you would look for a person with the same gender, same nationality, same, location where they live, and so on. And this will make your text more realistic. Or if you have an organization, you would look for another organization in your ontology of the same industry and country. Or if you have a city, you would also look for a city from the same country, for example, so that the context doesn't change that much. So let's look at some issues that you can get when doing replacements, either way. Let's look at this one, for example. The experiment was, the original text says, the experiment was conducted by Dr. Lane Staheli, Dr. Ignacio Ponsetti, and Professor Eugene Lloyd Griffiths. And anonymized text says, the experiment was conducted by Dr. Mary Smith, Dr. James Jones, and Professor James Michael Smith. What is the problem with this anonymization? Yep, go on, Anton. Yeah. So we introduced bias because Mary and James are like two top most popular names in the English language, and Smith and Jones are the most popular last names in the English language. You don't want your anonymizer to anonymize every person to Mary Smith or James Jones or Mary Jones or James Smith, right? That would be bad for your models that you later train on this data. But you can have like a different problem. Like if you just use randomization, your names may be too exotic, right? Which would also skew the reality. You don't want to have everyone in your data set called Jazala, Cyrilda, and so on and so forth, because that would not be realistic too. Another one, names have multiple variations. So as I mentioned, you would usually want to anonymize the same person in the same way throughout the text. So let's check this text. This text says, Elizabeth Martin was born in London in the family of teachers. Betty received good education. And after graduating from MIT, Dr. Martin dedicated her life to astrophysics. And here we have Elizabeth Martin, Betty, and Dr. Martin as one person. And we would want to identify all of these mentions as this is one person. But your anonymizer, maybe not that smart. And then you would have Sandra Bullock, right, was born in Cambridge in the family of teachers. And then you would have Ellie, meaning that the model doesn't know that Betty actually is a nickname for Elizabeth. A good nickname here would be Sandy, for example, right? So if it had Sandy, then you would be able to say that the text, kept its integrity. Now the integrity is broken. Now you have like a different person introduced here by your anonymizer. And then Dr. Bullock dedicated her life to astrophysics, for example. Let's look at other issues. Relevancy is like the biggest one, in my opinion. Your original text may say the US ex-president George Bush makes a birthday jump. And I think it was from a helicopter or something. So it wasn't like hoop or something. And the anonymizer may change it to US ex-president John Wick makes a birthday jump. The problem is that there has never been a John Wick president of the United States. I don't know, unfortunately or luckily. So, and then when your models train on this kind of data, they will keep producing hallucinations of such kind. Another example of relevancy. Brexit is London's decision to leave the European Union. And then your anonymizer says Brexit is Cleveland's decision to leave the European Union. And the whole Ohio state gets surprised, of course, by this decision. And when your models again train on this kind of data, they start producing more hallucinations. Another one, she got her PhD at MIT in 1999, can be changed to she got her PhD at IKEA in 1974. So it correctly identify MIT as an organization, but not, and replace it with a different organization, but not that kind of organization, right? Which again can corrupt your data. We can exacerbate the situation. She got her PhD at the Massachusetts Institute of Technology, and then you have MIT in brackets, which can be, say, your anonymizer correctly anonymized it to another educational institution, California Institute of Technology, but then it doesn't know that it identifies MIT as a totally relevant entity that is not connected to the Massachusetts Institute of Technology, which means that you will have this kind of situation where you have a random abbreviation here, and then your model will start generating random abbreviations. So that's the consequence. Logic. So say we have this kind of text, Yuri. I don't know if Yuri is here. This is a specific Yuri, who started the project on August 1st, 2024. By October 1st, he already had a POC, proof of concept. So he applied for the Llama Impact Grant on November 28th, when he learned that Meta now accepts applications from Ukraine. And here you have a timeline, right? So something started in August, then October, then November of the same year. And then your anonymized text would look like this. We would have Benedict, our friend here. And then if your anonymizer randomly substitutes dates, you lose the timeline, because then in the anonymized text, this Benedict person would have spent 8 years on the project rather than a couple of months. So when you're anonymizing dates, for example, it makes sense to find the first date, to then anonymize it, calculate the shift, and then shift the rest of the dates with the same span. The same goes about when you're anonymizing money, for example. You would want to preserve the logic here. You would want to preserve the ranges, the logical ranges, and so on. Okay, moving on. How about LLMs? So this is probably a question in your heads, like, can we just use a large language model to do anonymization for us? So I linked two papers here. The first one from my colleagues from Grammarly that I mentioned earlier, and the other one says large language models as advanced anonymizers. And these are like very recent papers. The outline is that large language models are good at anonymization and they generate predictable text. Sometimes it's too predictable, actually. They are on par with existing named entity recognition models. So if you take a named entity recognition model that is a fine-tuned Roberto, for example, a large language model wouldn't do a much better job. It would be on par. It would be of the same quality on the detection part. But there are multiple cons. Like, first of all, they do text distortion, a lot of text distortion. They would basically rewrite your text. You would not be able to re-identify the person, of course, so they are good at anonymization. But if you just need synthetic text and not like anonymized user text, you can just generate synthetic text with large language models. This is a different task to do. They introduce their own bias. This is like a whole separate meetup. We can discuss this. And meaning change. And usually it's not feasible to use a large language model in your architecture for your production traffic if you have a lot of user tags. They would just be too heavy, too computationally expensive, and not of and with their own issues, so to say. Let's now discuss a more interesting topic, anonymization metrics. So metrics is usually my favorite part in any NLP topic. So let's look how we can measure anonymization. This is what usually companies do, right? They would just measure named entity recognition, precision, recall, F1, and done, right? No, this is a very simplistic approach. As a reminder, we have like two goals, right? The first goal is to protect user privacy. The second goal is to get like good texts for any of our needs, right? For error analysis, research, training, and so on. There's a very nice framework that is called TILD, from the paper called No Intruder, No Validity. No intruder, no validity. Think about it. That has like two aspects to measure anonymization. One is the technical tool evaluation, which will basically be estimating the quality of named entity recognition. The other one would be information loss. Like, after anonymization, is your data still usable, or is it that corrupted that it's no longer useful for you? And de-anonymization, like, can you actually re-identify the person regardless of how your named entity recognition system worked? So let's look at these in more details. When we do technical tool evaluation, we evaluate the system's accuracy in detecting and tagging sensitive information. So basically, this is our named entity recognition and its quality. And we can measure like it's the quality in general or for each entity type separately, because you may be more interested in people names than, I don't know, in dates or locations or job titles. You can check the full match and the partial match of entities, because sometimes named entity recognition system, they would just catch the name or the first name or just the last name. And sometimes they would miss, one or the other, or they would catch part of the company name, not the full company name. And it's up to you on how to interpret these results, or whether these are true positives or false positives. The more interesting metric is information loss. Information loss evaluates how anonymization affects the utility of the data that you receive. And there are multiple ways you can approach it. Like, one, you can measure perplexity. So for those who don't know what perplexity is, it's a metric in natural language processing that measures how predictable the anonymized text remains. And there are multiple language models. You can use GPT-2, for example, to score the quality of your text. So you can score the perplexity, the predictability of the anonymized text and the predictability of the original text. You can compare them, and you can check like whether what is the difference. The higher the difference, the worse, the more the anonymizer corrupted your text, for example. Then you can do cosine similarity. It's also one of the metrics in natural language processing that is frequently used in natural language processing, where you would take a vector representation of your sentence, of the original sentence, a vector representation of the anonymized sentence. You would compare them. You can use like any sentence transformer models to do that. And then you would check like how close in meaning these two sentences are, or how diverged they became. You can check for consistency. So we discussed, for example, date timelines, money ranges, location relevance. You can check that the anonymizer doesn't place the Eiffel Tower into Žmerenka or somewhere else. And you can check, like the most important one, in my opinion, is the quality of the downstream tasks. Like, do you do text classification? Do you do error correction? Do you do sentiment analysis? You can train your models on non-anonymized text and on anonymized text and check like on public data, not on user data. And then check the difference, right, in quality to understand how much your anonymizer corrupts the data. And sometimes it does corrupt the data. Sometimes the text become unusable. And these are real examples. I didn't imagine that. So like the user wrote, "It's so nice to meet you," writing nice with a capital N. "I will get back to you." And the anonymizer decided that nice is actually Nitsa in Ukrainian, a city name. And then it also decided that will is a boy's name in the English language. And then it would anonymize your text to, "It's so Oslo to meet you, I Charles get back to you," for example, which makes your text completely unusable. The perplexity metric will tell you that, the cosine similarity metric will tell you that it changed a lot. Or text just become cute, right? So love and respect are important in any relationship. And it's a known issue that named entity recognition systems are biased toward the first word in the sentence. They would frequently identify it as a name or a person name in this case, or an organization name. And then you would get something like Samantha and respect are important in any relationship, which is not true. Moving on. The third metric is the risk of de-anonymization. The risk of de-anonymization is the metric that evaluates the system's capability to protect the individual's identities against attacks to re-identify them. Ideally, you would do a motivated intruder test. What it means that you have an actual person, you give the person the data, you anonymize user data, you tell the person you can use Google, you can use whatever you want, you can use like any database you want, try to re-identify this person after we anonymize that person's test. You can even do this on open corpora that discuss public people. You don't have to do this on your users' data specifically, in the first place when you're testing your anonymizer. You can do this, you can write, and you can even run an annotation task, for example, on Amazon Mechanical Turk, having like people across the world trying to re-identify text that you anonymized. If you don't have a budget, or you just don't want to do a motivated intruder test, you can do a second best thing. You can ask GPT to re-identify the subject. And it's an actually very useful way to use GPT. You just supply it with your anonymized text and you ask like, who am I talking about? And see whether the system can identify the subject or not. You can also run some automated metrics. For example, every subject in your text, like every person, has a list of identifiers. So for example, it can be a full name of this person, but then the location they live in, their age, their occupation, and so on. So you can collect this information and see how many of identifiers per subject did you anonymize successfully or not, and then average it out. Or you can find all mentions of a specific entity, like this person's name was mentioned in the text like 10 times, but it was mentioned as a full name, as a first name separately, as a last name separately, as a nickname, and so on. So how many of these identifiers have you anonymized? Because if the person's name is mentioned like 10 times throughout the text and you miss one, right, you can actually re-identify all the rest. So this is a good metric for de-anonymization risk. Or you can just look at direct identifiers, right, the ones that you classified as direct, and see how many of them were left non-anonymized. So all of these they don't substitute the motivated intruder test, but they help you understand the quality of anonymization in your system. Data. There are no data sets, just one for anonymization. Yeah, that's not the fun part. The problem is that anonymization as a task, text anonymization as a task, started from the medical domain. And most of the medical data sets that are referenced in medical journals and so on are closed ones. You cannot access them, like an average person cannot access them. But there's a very nice data set. I think the only one that is tuned specifically for the task of text anonymization, that is called TAB. It's linked here, Text Anonymization Benchmark. It is based on court cases, very similar to the ones that I showed that we have in Ukraine. It has a little bit more than 1,000 of them, so it's not like a huge database or something. a huge data set or something. It's published under the MIT license, which is great. Anyone can use it. And they included annotation guidelines because they manually annotated these court cases for a variety of things, for entity type, for whether it's a direct identifier, indirect, so quasi is the same as indirect with the identifier, or whether this entity doesn't re-identify anyone, so it doesn't have to be masked. It has entity IDs and entity mention IDs, right, if the entity is mentioned multiple times. And they even asked the annotators to annotate these entities for confidential attributes. And these are the attributes that GDPR identifies as ones that can be used to exemplify bias, which helps analyze this data set of whether the individuals of specific religion get like specific sentences in the courts, for example, whether there's any bias against specific religion, specific health issues, specific sexual orientation, and so on and so forth. This corpus is published in a JSON format. So like the entities are annotated in this way. And you would see here you have span text, Mr. Galip Yalman, right? And this person, this piece of text, this span is labeled as person. There's a entity mention ID and entity ID. There's a start and end in the text, like character-based. There's an edit type because this corpus was pre-annotated by a spacey named entity recognition model, like an open one. And then the annotators checked, corrected, removed, or inserted specific entities. Just, it usually simplifies the annotation when you have pre-annotated data. And the identifier type is direct because it's a full name. And then the confidential status is not confidential because it doesn't relate to any of the attributes. We actually, at Grammarly, we actually use this this data set as a test set to evaluate our anonymizer. It proved to be really useful in addition to the internal data sets. And do we have time for a teaser? Yes, we do. That's great. So you came here to this meetup, and I announced at the beginning that I also work in the Ukrainian NLP by night, right? So the question may arise, like, what do we have in terms of Ukrainian anonymization? The problem is we don't have any open tools and we don't have any commercial tools. Yeah, okay. This is the start. Now we can go. No. What we do have is a patented computer program that is called Linguistic Analyzer Shark, Лінгвістичний аналізатор текстів Акула, developed by the government agency Information Court Systems, Державне підприємство інформаційні судові системи. And it's used for automated pseudonymization of court decisions since March 2023. We reached out, like my master student, Andrei, reached out to the government agency information court system, asking for any details about how this anonymizer was developed, what quality it has, like how they use it, whether we can look at it, use it, do something with it. And the reply, they did respond to us, but the response was that all the information is confidential and they cannot share anything. But we do need an anonymizer for the Ukrainian language, right? Because we want to ensure data privacy for people writing in Ukrainian, and especially in the current geopolitical context when cyber threats are a problem. And we want to automate manual anonymization of data in the public sector. So I mentioned this data.gov.ua, the portal of open data, and the multiple data owners are publishing data there, and there are recommendations of what they have to anonymize, right? And they do this mostly manually. We would like to automate this. And also, like a teaser, we're developing in the Ministry of Digital Transformation and Center for Democracy are developing the voluntary code of conduct for the developers of AI systems in Ukraine. And this code of conduct already asks the developers of AI systems in Ukraine to anonymize user data. And this all leads for Ukraine to get aligned with European data protection standards. I don't think we will adopt GDPR anytime soon, but we are moving in the direction of Euro integration, and this will become an issue. So what can we do? How would we build an open anonymizer for Ukraine? Let's see what we already have. We actually already have a lot. First of all, we have a golden corpus of named entities, NER UK 20, manually annotated for 13 entity types. It contains text from the Наші Гроші website, which is like riddled with entities. There are so many entities there. It's really cool. And also a part of the brown corpus for Ukrainian language, which has fiction, laws, scientific literature, anything. So social interactions and so on. It's a very multi-genre corpus. It was released, this corpus was released this spring. There's a paper attached to it. You can, and they linked it so you can investigate it. This is something we developed in the Lang UK organization. We also have silver corpora of named entities, polyglot, NER, VKN, and Euchre synth. They are automatically annotated and only for 3 entity types. So this is just person, organization, and location, which is like not super useful, but there's a lot of data. So, you know, it may be useful for some experiments. We also have like at least 3 NER models. I think there's a 4th one, the Flare one, that I didn't mention here. So the first one here is trained already on the latest corpus, NER UK. It's published in Hugging Face. It's an open model. You can use it for all of these 13 classes. There's a Spacey model trained on this automated silver corpus, UKR synth, and there's a Stanza model trained on the first version of NER UK. So Ukrainian NER systems are already in popular libraries, and there's a Hugging Face transformer-based model. This is a fine-tuned Roberta that you can use. There's also a subcorpus of anonymized court decisions. It's part of UberText 2.0 corpus. It was extracted from this open portal of data. It's already anonymized, right? But it can be useful because it aligns well with this tab corpus that I mentioned that was published for the English language. So we already have some, foundation to start building an anonymizer for Ukrainian. And this is a teaser. A master student of mine at the Ukrainian Catholic University, Andrei Ruda, is writing his master thesis on the topic of automated anonymization of court decisions in Ukrainian. And what we want to deliver is to create a library for generating synthetic entities in court decisions, because currently they are anonymized. We want to artificially de-anonymize them, right? We won't be trying to find the exact individuals, but we can substitute the masked entities with some real world looking like entities. Then we'll be able to create a synthetic corpus of annotated court decisions, like similar to the tab corpus that I just mentioned. Build an evaluation framework for the Ukrainian language anonymizers, similar to the evaluation framework that I mentioned, and hopefully an open anonymization library, at least the basic one, for a handful of entities that we can start developing and improving further on. And here I wanted to mention some of the challenges of generating replacements for the Ukrainian court decisions. Like, first of all, Ukrainian is very different from English because it's a syntactic language and English is an analytical language, which means that in Ukrainian, for example, we have the grammatical category of gender, and a lot of the words in the sentence should agree with the gender. So if we look at the examples, the first one says, тієї ж ночі особа 1 з 5-го поверху в під'їзді адреса 2 викрав 34 метри підвісного кабелю, чим спричинив збитків у розмірі 440 гривень і 64 копійки. And we see the word викрав here, which is a verb, and it should agree with the masculine gender, grammatical gender, and we know that особа 1 should be de-anonymized using like a male name and last name. The other one says, допитана в судовому засіданні обвинувачена особа 1 свою вину в скоєному визнала повністю. And here we have words and we have adjectives and we have nouns that all agree with the feminine gender. So when we do de-anonymization, we want to use like something like Білий Тарас Іванович for the first person and Ткаченко Марія Петрівна for the second person, so that they agree, but not vice versa, because otherwise we would get like non-realistic texts. Then Ukrainian language also has declensions, which means you have to decline, all right, the first names and last names and patronyms. So here, for example, this one says, визнати недостовірною і такою, що порушує права особа 1 на повагу до його честі та гідності. We also have gender markers here. Та ділової репутації інформацію поширеною особа 2 про те, що особа 1 восени викрав з її городу гарбузи та капусту, взимку викрав з її двора та переніс до себе дрова, весною викрав з її веранди насіння цибулі сіянки, а вночі знав з даху з її хліва лист шиферу. Yeah, these are real court decisions, I'm sorry. So in this case, like the first one would have to agree with the genitive case, right? The second one would have to agree with the instrumental case. And the third one would have to agree with the nominative case. And then we would have to generate to keep the determiners, because to keep the identifiers, because osoba 1 is mentioned twice. So we would have to do declensions properly here, like Білого Тараса Івановича, then it means that we can put like Білий та І here, for example. Okay, moving on. Some of the entities are very ambiguous. Like in court decisions, they have this entity that is called information. and it can mean whatever you want. It can be in the name of organization, it can be the name of a military unit, it can be a name of a website or an app, or like just something very weird here. So we would have to classify them by what they can mean, in order to generate some stubs for it, some dummy entities for it. And there are more challenges because depending on the type of court case, you may or may not need to anonymize everyone. Like in civil court cases, like the names of the judges and the names of prosecutors are usually open. In criminal court cases, everything should be anonymized. Or like there are public and not public persons mentioned in these court decisions, and you don't have to anonymize public persons there. So stay tuned for the results of this project. I hope it works well. We'll see how it goes. And thank you, persons, so much for your attention.
So can we ask questions?
Yeah, sure. Vanya is here. She's
great. Yeah,
please start, Denise.
Sure. So, first of all, thank you very much for your talk. And I have one question and two comments. So my question is, have you heard anything about differential privacy? Because you can also, like from the user side, you can construct text embeddings, add noise to this text embeddings and send them to the server and use these text embeddings for model training. Or you can introduce noise in model gradients. So do you have any opinion about differential privacy?
Yes, sure. I think it's a good technique, but it doesn't serve all the purposes, right? If it serves your purpose when you need just to process the data and that's it, it's great. Like it's a good technique. If you need to store the data, actually, it wouldn't work, right?
That's so I agree.
Yeah, but it's a good anonymization technique. It just has its own, I guess, its own use. Yeah, its own purpose.
So it's addition, and also like another comment, also to the same quite setting, you can also use federated learning for training your models. So once again, not collect the whole data set on the server side, but you can use federated learning plus differential privacy to train your models, and in that case, you don't break privacy. And also another common and interesting topic is how do you collect data? Because, for example, you can have 10 clients and you collect the data from these clients, but one of the clients can be malicious. So imagine somebody wants to break your business and this client can generate poison data. And the question is, what will be the behavior of the model in this case? So it's quite another separate topic.
It's a separate topic. We could discuss jailbreaking and so on. It would take like another hour, I guess.
Yeah.
So thanks. It's a good note. Yeah. Thanks.
Yeah. But about differential privacy, so it's quite popular technique. I know that various regulations recommend it to use in existing applications.
Yes, but again, it doesn't meet your needs if you need to actually collect the data. So it has a different purpose. Thank you.
Good evening. So I have one question about maybe there are some metrics of similarity in data anonymization, because me and my team are developing AI that will work with restaurant meals, and we are training it on existing restaurant meals and description. And this is a very important question: how much we need to change the restaurant meal, for example, the description of a burger or of a pizza,
so that you don't generate a similar one, so that you don't you're not accused of plagiarism.
Percent of similarity, yes.
Percent.
Yes.
So it's a bit different. It's not about anonymization per se, right? It's not about anonymization. It's more, I guess, in the topic of paraphrasing or something, because I don't think there's an exact number you can use. I think you should have your own metrics for this specific task again, right? The metric should satisfy your goals, and your goal is to have, I don't know, a happy customer. So if you generate this meal and the customer is happy, then this threshold works. And if you generate a meal and it's very similar to the previous one and the customer is not happy, then the threshold doesn't work. So I'm a believer that the metrics should should be very closely tied to the goal that you're trying to achieve. Since I don't know how similar restaurants menus have to be, you have to look at your audience, I guess. You have to have a group of people, human annotators. Usually you have human annotators that judge these things, and then you can tune your metrics, to align with human judgments, I guess.
Thank you, but it was about plagiarism.
Plagiarism.
Not to be
text generation, right? But if I understood correctly, the problem is that you have a real menu and you don't want to generate the same one, right? You want to generate a different one.
Yes.
Yes. So this is very similar to plagiarism for me, like for detecting plagiarism for me. That's why I would use like the same metrics. Not it's less similar to anonymization, I'd say, because in anonymization, you actually want to have the text very similar to the original text. Like it's a different problem. It's vice versa, but you don't want to break personal privacy.
For example, if we like the menu description, but there are, for example, the text that belongs to restaurant, can we anonymize it to use in our model training? Or it is
I wouldn't recommend anonymizing it. I would recommend paraphrasing it.
Okay.
You would take this menu, you would ask him, I don't know, you can ask GPT-4 to paraphrase it in 10 different ways, and then use this synthetic data for training, for example.
Okay, thank you.
Yeah, that could be a better solution.
Any other questions?
Can I ask a question?
Yeah, sure.
Sure. Go on, Andrei.
Yes, thank you. My question is, you said on your presentation that using LLMs, it's very complexity. Firstly, for the companies that have a lot of data, yeah. But do you have some test moments, for example, use not so large LLMs mainly for generation fake data already on anonymized data? It's not so complexity and it's not take so much time. And my main question, if you test this, what limit of size of the limits if you use such approach? Thank you.
The limit for the size Andrei, actually, whom I mentioned today, is trying to do exactly that with Llama 3.1. And I don't recollect.
Llama 3.1 have a few options of size.
Yes. I don't don't recollect which one he's using, but he's running it on Mac, so I guess the smaller one. The problem is that so currently this project is work in progress, so I cannot say about the results. But specifically, for example, for generating entities, I don't think he tried it. I think he tried it only for detecting like the grammatical characteristics of the entities that we want to unmask. So I don't have, unfortunately, I don't have a good recommendation on generating replacements with LLMs, with the smaller LLMs. The papers I linked, and unfortunately, I also haven't found any papers on using smaller models doing exactly that task. The papers I linked used GPT-3, GPT 3.5, GPT-4. These two papers, and they already have problems with like meaning change, with bias, with rewrites. So my guess would be that smaller models are even worse in that case with that task. But that's hypothesis. Sorry.
Okay, thank you. And my tips, not use Llama 3. I test a lot, and this is just awful. Not Llama.
Okay, I'll make sure to let him know. Yeah.
My question would be about voice. So we are recording the conversations with children, Ukrainian language. We are trying to develop the voice recognition for Ukrainian language, for children Ukrainian language, which is like very difficult. So first question is like voice itself, should we anonymize it? And the second question is like more tricky. We have the consent from parents, and they actually allow us to kind of talk to children and do those recordings. And of course, in content of those that speech, there is no like sensitive data, but the voice itself again may be sensitive. So
I don't think we have any laws, at least I don't know about any regulations in Ukraine that prohibit you, that enforce you to anonymize voice in any way. And I don't think there's a good way to de-anonymize voice again from the recordings that you're making. But I would be cautious about saying that children don't mention any sensitive stuff, because they do mention sensitive stuff. They may mention their parents' names, where they live, I don't know, some stories that happen to them mentioning specific people and their full names. And if you are to store this data, like a good practice would be to anonymize this data. Mm-hmm.
Sorry, may I add a comment here?
Sure.
I sent in chat a very recent paper, how to use differential privacy for speaker anonymization. It was published like less than 1 month ago, and I know the first author, and it is a state-of-the-art methods of differential privacy exactly for speaker anonymization, because in speaker anonymization, you don't only have text, you also have intonation, and based on intonation, you can recognize person. And the question is how to deal with it also. So it's very interesting paper, how to work with it.
Great, thank you so much.
Yeah, and this is the first author.
Yeah.
The first author is Ali Shahin. He knows a lot of in differential privacy. He's researcher at Brave browser, if you may know. So this person introduced a lot of things in privacy, in differential privacy. So very, very cool paper.
Thank you, Dennis.
Any other questions? Because we don't have in Slido. Yeah.
My name is Maria, and I want to say in advance that I'm not tied to any AI development, or like the only thing I can understand about AI is from my informatics class. But as a casual user and like regular audience, I want to ask you, what if your AI learns something bad from users and you de-identify their data? Who will be responsible for the harm that they cause?
The developer of that AI.
Okay.
The only people are responsible, like, that you cannot make the system responsible. So yeah, the developer is always responsible.
Okay.
In all responsible AI frameworks, in all regulations, everywhere, the developer is responsible. Yeah.
Developers, you mean like companies, like as a who?
The entity that develops, you know, because it may be Mariana that did this development, it may be the company that Mariana works for that did the development.
Developer, never the operator.
Yep. Ask Santon.
My actual question is, would you comment on an anonymization of bilingual or multilingual corpora? Do you think it's applicable? Do you think it can be done? And do you think it's easier or harder than with monolingual corpora?
Yeah, so coming back to the teaser that I shared, the hope is that after the basic part, the basic anonymization library is done, we can extend it to either other domains or other languages. And the bilingual setting is a very interesting direction, because we would want to have a Ukrainian English bilingual model for anonymization. Specifically because since we want to do Euro integration, we have to translate all of the court cases, decisions, legislation, and it goes back and forth, and the number of documents is massive. So yes, it makes sense to go into the to use multilingual models for that, to use aligned domains for that, which is why it makes good sense to have a corpus of court cases in Ukrainian, corpus of court cases in English, that can be share the same context, share the same domains, and hopefully the multilingual models will work better, you know. Yep.
Yeah, you could possibly you could possibly infer that this name, let's say in the Ukrainian corpus, should be anonymized or is an entity because it's an entity in the other language, let's say in the English part of the corpus.
Sure. Yeah. Yep.
Right.
Yeah. Multilingual context helps.
Okay. Yeah, that's what I want to say. Thank you.
Yep. That's sad. Yehor, I'm not sure what you were talking about. Could you clarify? Oh.
Yeah, that's why I didn't ask.
That's about responsibility.
Yeah.
Oh, okay. Okay, all right.
Any other questions?
Okay, everyone in there has such good English pronunciation. I'm impressed. So kudos to everyone here. That's cool. Thank you, Andriy. Very nice compliment. Okay.
So we can finish.
Yep. If there are any other questions, thank you so much for the attention. Hope it was worth your while.
Thank you so much for your time. I will send you an email with presentation, I hope, if Mariana will share with me, and with recording, just in case you want to come back and to listen some part of the Mariana representation. And if like for other meetings that we will have, of course, I will send you email. So keep in touch with me. Yeah.
Okay. Thank you. Bye, everyone. Bye, everyone in Zoom.
Thank you so much.
Thank you for joining.